Hello everyone. Our project focuses on building a low-array large language model, aiming to provide it accurate and reliable lead constellations and questions answering for non-professional users. Here is the outline of my presentation. First, I will introduce the background and motivations of our project. Then I will explain the overall framework, followed by the model design and dataset we used. After that, I will present the results of the fine-tune experiments and the RAG model evaluations. Next, we will look into the hybrid and ablations and analysis to understand the impact of each component. Finally, I will include the presentation with some key finds and future directions. In recent years, large language models have achieved remarkable progress in general questions answering the reasoning tasks. However, when it comes to league applications, they still face several challenges. League language is highly specialized, logical, and knowledge-intensive, requiring precious citation of league articles. General-purpose models like ChatGPT or Qiu often produce or incoherent league information. On the other hand, existing league LLMs such as DISC-LLM are powerful but require intensive computations, resources, and training time, which limits their accessibility. Therefore, our goal is to design a lightweight and adaptable league LLM that can perform league considerations tasks efficiently. Based on these challenges, our objective is to develop a law-oriented large language model that achieves strong performance with limited computation resources. We propose a hybrid approach, combining LoRa fine-tune and retrieval augment general RAG. The fine-tune process allows the models to better understand league reasoning and context, while RAG enables it to dynamically access external league documents, reducing and improving factual accuracy. Ultimately, our goal is to deliver a lightweight and practical league QA system capable of providing accurate and reliable league constellations for real-world users. Our overall framework follows a hybrid design combining fine-tune and retrieval argument generations. When a user submits a league question, the fine-tuned Qiu model processes it using its internal reason ability. Meanwhile, the RAG model encodes the questions with a sentence transformer and retrieves the most relevant league article from the FAISS vector database. Finally, the retrieved information is merged into a prompt, allowing the model to generate an answer that is both context-aware and factually accurate. This framework enables the system to reason like a lawyer while staying grounded in real league documents. Our system operates in 5 main stages. First, we perform data processing, cleaning, and formatting the league QA data for supervised fine-tuning. Second, we apply LoRa fine-tune on the Qiu 3B model to efficiently learn legal language and reasoning patterns. Third, we conduct knowledge embedding by encoding all league documents using sentence transformer. Fourth, FAISS index is built for efficient semantic retrieval of relevant articles. Finally, during hybrid inference, the retrieved league documents are combined with the model's internal knowledge to produce accurate and logically consistent league response. We selected Qiu 34B instructs as our base model, a medium-sized instruction-tuned model with strong reasoning and Chinese language understanding ability. For fine-tuning, we use the Llama Factory framework, which provides stable support for various pyramids efficient to methods. Our chosen approach is LoRa, which inserts small trainable metrics into the attention layers, allowing efficient training with limited GPU resources. The main objective is to adapt the model to language and reasoning tasks, enabling domain specialized without large-scale retraining. The dataset we use is DISA Lore SFT, a supervised fine-tuned dataset realized by Fudan University's DISA lab, specially designed for league dialogue and reasoning tasks. It includes two types of data: binary pairs query response, which training the model's reasoning ability, and triplet reference query response, which enhance external knowledge usage. In our project, we fine-tuned using only the binary pairs. Totally 166,758 samples, trained for 3 epochs and around 31,000 steps. This desktop allows the model to efficiently learn league discourse pattern and reasoning logic while keeping the training lightweight. For evaluation, we adopted the DISA Lore Eval benchmark realized by Fudan University's DISA lab. This benchmark is comprehensive and divided into two major parts. The first part consists of objective questions or multiple choice exams, covering 3 difficult levels: easy, medium, and hard, and 60 different sources such as the National Judicial Exam and the CPA exam. Harder exams like NJE and CPA contain complex reasoning problems, while LBK and PFE represented simpler factual questions. The second part includes subjective questions, about 300 real league cases connected from consultations and judicial documents. These questions are more realistic. For example, how many power plants constitute a crime and are automatically evaluated by GPT 3.5 Turbo along 3 dimensions: correctness, completeness, and clarity. The results show that the concurrence reflects the difficulty of each exam. Harder ones like the National Judicial Exam and CPA scored around 40 to 60%, while easier ones such as LBK and PFE researched 50 to 80%. There are several possible reasons. First, the training and evaluation tasks don't match. Our data are QA pairs, but the benchmark uses multiple choice questions. So the fine-tuned models tend to generate full answers instead of choosing options. Second, catastrophic forgetting may have happened. Fine-tune on QA data can override the model's general knowledge. Third, our training settings, like the learning rate or number of epochs, might be too high, causing overfitting. Lastly, some evaluation questions are old and may already appear in pre-training data. After fine-tuning, the model could lose that period knowledge. Overall, the results suggest that adding RAG in the next stage could help improve factory accuracy and stability. We introduced the retrieval arguments generations RAG model to improve factual accuracy and domain coverage. The process works as follows. First, the user's league query is encoded into a dense vector using sentence transformer. Then we research the FAISS vector index to retrieve the top K most relevant league documents from our LexRAG corpus, which contains over 60,000 league articles and cases. Next, the retrieved content is concatenated with the query to form a new input prompt. Finally, the Tian 134B model generates an answer grounded in real-linked text. This pipeline effectively combines semantic retrieval with language generation, enabling the model to provide legally sound and contextually accurate answers. We evaluate the RAG models on the DISC low-level benchmark, and the table summarizes the accuracy improvements across 6 exam categories. Overall, RAG increased the average accuracy from 65.13% to 66.98%, showing a consistent gain of 1.85 percentage points. The performance variability by domain. The largest improvements appeared in the patent agent exam PAE with 5.41%, suggesting that RAG is particularly beneficial for tasks requiring explicit legal reference. In contrast, the National Judicium exam improved ours slightly, as its problems rely more on legal reasoning than factual retrieval. These results indicate 3 main takeaways. RAG strengthens factual grounding, reducing hallucinated or unsupported answers. It boosts recall on specialized legal terms and provisions. It has limited effect on pure reasoning tasks. In summary, integrating RAG significantly enhances the model's accuracy, factual reliability, and domain robustness, especially for knowledge-intensive questions. We also ran a hybrid and Bayesian study with 4 setups: the baseline model, fine-tuned only, RAG only, and the hybrid combinations. As shown in the table, fine-tuned alone performs the worst, with accuracy dropping to about 52%, showing clear overfitting and forgetting. RAG alone worked best, reaching nearly 67%, about 1.8% higher than the baseline. This means the retrieval arguments helps the model stay factually grounded. The hybrid model recovered slightly compared to fine-tune alone, but still fell below the baseline at around 57%. This suggests that although RAG reduced forgetting, the fine-tune model's internal knowledge drift still limits accuracy. In short, fine-tune improves legal reasoning and language fluency, while RAG strengthens factual accuracy and knowledge recall. In the future, we plan to align fine-tune with retrieval inputs and adjusted hyperparameters to better balance internal and external knowledge. To conclude, we built a law-oriented large language model that combines LoRa fine-tuning with retrieval argument generation. Fine-tuning helps the model reason better in legal context, while RAG improves factual grounding and citations accuracy by adding external legal knowledge. On the DISC lower-level benchmark, we observed that fine-tuning alone suffers from catastrophic forgetting. RAG alone improves accuracy by about 1.8%, and the hybrid model partly recovers but still needs deeper integration. For future work, we plan to fine-tune the model on the retrieval argument inputs, build a dynamic system to update legal knowledge, and explore interpretability and human-centered evaluation. In short, fine-tune boosts reasoning, RAG boosts factually, and combine both is the key step toward a more reliable AI legal assistant. Thank you all for listening. This concludes our presentation. We really appreciate your time and attention, and we'd be happy to discuss any questions or feedback. Thank you.